Hello, everyone, and thanks for joining us today on Coffee with Vitex. My name is Priya, and I'm the marketing lead here. So this webinar will be uploaded to our website tomorrow. I'll be dropping a link to the web page shortly in the chat. Today's topic on 400G optics for data centers will be presented by Michael Ko. Michael has over 20 years experience in fiber optics engineering and sales. He holds optics degrees from the University of Rochester and USC. He worked on fiber optic sensors at Northrop Grumman, was a product line manager and Korea country manager at JDSU before joining Vitex. He's currently Director of Business Development here. Michael's presentation will be about 25 minutes, followed by a Q&A. If you have any questions, please type them in the Q&A box. And now over to Michael.
Thank you, Priya. Okay, hi everybody. My name is Michael. Thank you for joining. Good afternoon. I'm joining you from New York or New Jersey area. Let's see. Okay, so 400 gig is a big topic, and by no means, I'm not the expert, but we thought it would be useful to share some of the background information. And as many of you know, PAM4 is the critical technology to enable 400 gig. So we're going to touch upon PAM4 a little bit and different data center applications that 400 gig can be used. And we also share some quick industry survey of typical 400 gig performance. And there's been some interesting also development while I say 99% of the products out there is a DSP based. For the reasons we're going to talk about, but there's just some effort going on for analog-based solutions. So we'll touch upon that a little bit. And then lastly, we'll share some of the available examples of our 400 gig products. By the way, before I begin that, a lot of these slides were prepared by my colleague, Eric, but unfortunately he couldn't make it. So I'll do my best to present all the information correctly. Okay, so let's talk about the background a little bit. So as you know that there's a lot of a chart you can review, but there is a tremendous amount of the growth in traffic, need for bandwidth, and obviously that's really the main driver behind all these activities for the higher data rate, 400 gig, 800 gig. And rather than showing you these some of these graphs, I thought it would be interesting to show actually what happens. So this is my couple of my kids with our neighbors doing a play date. And you can see these kids are literally glued in front of the computer to the internet. This is happening across the country, well, actually across the world. And in fact that all of us are now glued to the in front of this Zoom meeting. So clearly that there's a lot of need, and this will be unabated for next 5, 10, 20 years. Who knows, right? So, by the way, this is my son right here. So, in terms of 400 gig standards, as many of you know, the IEEE really drove this for several years. And standard body approved 200 and 400 gig standards back in December 2017. So it's been almost 3 years. And also other organizations such as ITU and OIF, they developed the standard for more on the longer transmission side. So as an example, 400 gig ZR, that can cover 80 kilometer based in coherent technology. So all of this basically set the foundation for 400 gig standard, and that enabled module manufacturers and companies to introduce optical modules. So these days, you will see 400 gig modules and technology being used in data center, interconnect, metro networks, and also longer transport networks. This is some sales forecast that I got from LightCounting, the industry research company. The amount may be it may not be exact, but I think the trend is obviously more or less correct. So you will see that really the 400 gig shipment really starting to happen, I would say second half of 2019. So this shows maybe couple $2 million worth of a shipment. Then last year it grew quite rapidly to, according to this chart, about $500 million last year. And we expect more shipment, more sales in 400 gig this year, and it's going to continue. Obviously, this is a future projection. You'll see that there's even slight red for the 800 gig transceivers. So some of the leading industry players will introduce the samples. They're already working on it, and samples will be available later this year. And I'm sure that they'll get adopted also in the next several years. So since we have a little bit focus on the data centers, and that's been the main driver for many of these technology development, it's kind of useful to have a qualitative comparison between kind of old and new, or traditional versus cloud computing. I mean, essentially that scale, from smaller scale to large, some really big companies, we call it hyperscale data centers. The networking architecture, more or less from, I guess for simple description, more of a top-down 3-layer architecture to spine and leaf. And the way I look at it is that, obviously that it's better to have a any-to-any type of a network. So you can have a almost like mesh network going, and that drives up that obviously improves the capacity and capability of your network or your data center. But that requires also higher speed. Your demand for optical modules per server goes up, and your demand for the data rate obviously also goes up as well. And this is another snapshot of where, say, 200 gig or 400 gig modules can be used in different spots around the spine and leaf-based data center architecture. So let's talk about PAM4 a little bit, because that's really what's enabling these 400 gig modules these days. So before we go to PAM4, it's interesting kind of a look at the recent or past development. This is a chart titled "Increase in Lanes," and 100 gig is now pretty much mainstream, and it's been that way in the last several years. So in 100 gig case, when the optical modules were developed, obviously from optics perspective, we love WDM. So in the optical modules, we had the full wavelengths in one fiber. So that's another way to increase the lanes. Or we could actually have physically more fibers. So in this case, we call it PSM4, parallel single mode fibers. So you have a full wavelengths, one wavelength per each fiber. But basically, this is just different ways to increase the lanes, and they give you more capacity. But even then, this can run to some limitation. So as we're going to talk about later, there are now products available. We call it single wavelengths or single lambda 100 gig, and a lot of those products do have to employ PAM4 modulation to enable the 100 gig on one single fiber or one single lambda. So why PAM4? There are basically 3 ways you can increase your transmission rate. So you can increase the data rate. So we've been doing that for the last 30, 40, 50 years. We can use more lanes, as you just saw. Or the other way is a high order modulation, where PAM4 comes in. So this is a lot of physics, but essentially, PAM4, when you increase your data rate to say 50 gigabit per second, really your RF insertion loss is just way too high, and it becomes almost impossible to manage. So PAM4 essentially allows you to send them more information in a given bandwidth, so that in this case, by going from NRG to PAM4, you can still maintain the essentially same bandwidth, but you pack the more information into a symbol so that your RF insertion loss becomes more manageable. And we do have full data correction technology and other things to compensate for that type of challenges. So this is a very doable way to increase the data rate based on the existing technology. But just like any other things in technology, there's a trade-off. So in this case, that we are essentially trading up signal-to-noise ratio performance by using PAM4. So this is this is the NRG eye diagram that we are all familiar with. And by having PAM4, we have a multiple eyes. So you sacrifice your signal-to-noise ratio, and because of that, you need to use a DSP to enable this modulation, and also the full data correction needs to be used to compensate for this signal-to-noise ratio degradation. But that also introduced the penalty in terms of power, latency, and cost. And because of a complexity, the optical modules, there's a, I guess, new quality measure people use called the TDQ. And in this case, this is like a penalty. So actually, the lower the number, it's the better. And also, there's a way you can measure the eye openings or vertical eye closure in this case. So obviously, this is a lot more complicated than when it was an NRG, but this is a agreed upon defined way you can measure the eye closure, so you can compare the performance and have an actual measurement. So what are some products get used in data center applications? I'm sure a lot of you are familiar with these different form factors. And this is courtesy of Ethernet Alliance. So we have different form factors that's available. CFP8, that's probably mainly used by service providers for long haul or even ultra long haul applications. Onboard optics, there's a lot of interesting work going on, but it's relatively still early. So for our purpose in 400 gig, really that most of the modules that's commercially available is either in QSFP-DD or in OSFP form factor. Depending on the customer's preference and industry alliance, different companies may prefer different form factors. Again, that both of them has pros and cons, but really these are the two, the predominant factors that's available in optical modules, pluggable optics currently for data center applications. This is a little busy chart, but it's a nice snapshot of where different data rates and what type of modulation gets used. So in this case, this is within the data center. If you have a one-to-one connections, typically you will see still a lot of 100 gig modules, from 100 meters to 2 kilometers. And obviously now the 400 gig are being introduced, SLA to FR4. And in the breakout application where you could have a lot of applications where you could, before you had a 40 gig to 10 gig, 100 gig to 25. So in this case, with a 400 gig, you can have a 400 gig to 4 by 100 gig. So you can have a breakout to your switches to servers. So these are type of modules that you may see in that type of application. Inter-data center obviously require much bigger, much longer distance. So I think that PAM4, I think the limitation is around 40 kilometers. So if you go to beyond that, a lot of industry players use a coherent technology to get to like 80 kilometers or even beyond. So we talked about one-to-one connection is a fairly straightforward, but we thought that this breakout application is something interesting. So this is a type of connectors or the layout that you may see. So again, this is in the case of a 400 gig to 100 gig connections. A lot of optical modules will have MPO connectors on the 400 gig side. On the 100 gig side, you'll have a duplex LC. We've seen some of the product that uses what's called SN connector. It's a fairly new connector supported by like only a few players, but those products are also available. So, this allows you to have a nice connection from your, say, 400 gig switch to various 100 gig servers. So let's look at some of the key performance parameters. This is just an example. It's more of a format and formula that's more interesting. So for example, to generate a sensitivity mask, you can actually look at the different numbers from the parameters, and by charting these numbers out, you can generate a sensitivity mask for PAM4 based modules. And this applies to pretty much all PAM4 modules in terms of definition and approach. And another thing that's interesting, that's useful is this CMIS interface. I look at it as a, I guess, sophisticated version of DDM that we have for the SFP, which is the communication interface between the host and modules. So the latest version, I believe, is the CMIS 4.0. And it does have all the things that we used to see at the DDM, where you can monitor status, and there's a lot of parameters you can measure and you can look at. But what's, I guess, interesting is there's a lot more powerful tools that's available. So you can actually debug it. You can turn it on and off, a lot of features. And this really gives you a powerful tool to troubleshoot in many, many details through this interface. So for those of you who are about to use a 400 gig, we definitely recommend that you take the advantage of this capability provided by CMIS. So here's some, I guess, key building blocks and some numbers for the 400 gig products. So there's a DR4, FR4 that really refers to the more or less reach from 500 meter to, you can go all the way up to 40 kilometer. And, this is a typical, the line rate you'll see on the electrical side and optical side. And these are the key building blocks in terms of optical connectors and lasers and receivers. Here are some key specifications that you will see on optical modules, and these are more or less defined by the standard, the optical modulation amplitude, the TDQ that we talked about, sensitivity based on the OMAs, bit error rate, and powers. I think that it's running, anywhere between, I guess, 10 to 12 watts, and most of the modules is all indoor or the commercial temperature. And again, the latest interface is version 4.0. So pretty much all the products in the marketplace uses DSP. And that's because because of that, PAM4 gives you such a great advantage, but that also introduces a lot of a penalty. So DSP does a great thing to enable all these technology and performance possible. But I believe that InFi is probably the most popular, mostly widely used solution in this case. But obviously, just like anything, again, that there is a trade-off. So there's a cost and latency, and potentially thermal management can come into play. So this is just some information that, like, this was a simulation. I think that I'm sure the technology is getting better, but the DSP can potentially generate or consume about 4.6 watts in this case. So there is like another MSA, as some of you may be aware, called the Eye MSA, and focus is that they want to reduce the complexity by using as much as possible what's already available in NRG or analog world. So there has been some demonstration happen at CIOE or OFC. A lot of companies are active in this space, and we have a partner, Optimind. Also, they has been making some impressive progress using the analog CDR. So this is the example performance on 400 gig AOCs. So there's no DSP, so the power consumption is lower. In this case, roughly 7.5 watts per each end, so per transceiver. And the reaches are up to about 100 meters using OM4 fiber. Clearly, latency performance is better. So some applications, it may not matter that much, but if you are into like high performance computing or some type of a real-time AI application, then literally some nanoseconds may make a huge difference. So some applications may require this type of performance. And potentially at high volume, we think that you can achieve a lower cost because of a less complexity. But that's depending on there's a lot of interesting, also great progress being made on the DSP side as well. So these are just available options to industry customers. So this is just the example of a performance, and you can see the optical eye, the PAM4 eyes across the 4 channels, very nice and stable. And this is the performance over temperature. So you can see that, again, the performance is very stable over temperature. So let's look at the available 400 gig portfolio. And again, this is a snapshot of generally what's available in the marketplace. So as I mentioned, the QSFP-DD and OSFP transceivers and AOC, I say that they've been really shipping in volume really in second half of 2019. And the analog, that's relatively new. So that's been shipping since late last year. And we work with our partners. So a lot of our upcoming information is from InnoLight and Optimind. So these are like available QSFP-DD products, and from the leading manufacturers, the performance will be more or less similar. But you have a SR8, DR4s, FR4s, and the traditional DSP-based AOCs. And these are the typical performance and parameters that you will see in these optical modules. And you'll see similar things in OSFP form factor. So that's similar information in the different form factor. Since we are talking about PAM4 modulation, we might as well just include some 200 gig information. So these are some of the 200 gig information on the SR4 and FR4 with the key parameters. And for the analog PAM4 AOCs, these are the products that's currently available with key reaches, again, up to about 100 meters on OM4 fibers, and using PAM4 modulation, but without DSP. So, this slide was a little, we think that it's just always the customer says, like, how much do they really cost, right? So, and most companies, because that there's so many different factors, it's difficult to give you one number, but, because it's for information purpose only, again, just with a caveat that this is a budgetary pricing, ballpark estimates. These are rough pricing that you may see in the marketplace. Frankly, let's say that if you are like Googles of the world and you buy 10,000 of them, clearly your pricing will be much, much better and lower. If there are customers who may need a few devices, the price can be a little higher. Again, this is only information purpose only, but it just gives you some reference points on what are some pricing points that's available for different PAM4 modules and 200 gig and 400 gig modules. So I know that was I mean, you could spend a lot of time on 400 gig, and we at least wanted to touch up on some of the key points. So, I mean, 400 gig, especially on the large data centers, they're already using it, and we think that it'll propagate down to, other data centers, enterprise, and edge data centers, in this year and in the next couple of years. So they're already being widely used. And performance has been pretty much proven now that it's been shipping in the last couple of years. And as you saw from previous chart, the cost is actually coming down very fast. Again, because of the, once you achieve the economies of scale, the cost can come down really fast, and that'll obviously accelerate the adoption of a 400 gig. And all the products out there are pretty much all DSP-based solutions, but because of an effort from Open MSA, analog and DSP-free solutions are also becoming available, and that could be interesting solution for some applications where low latency or thermal management is a critical issue. So there are a lot of different approaches, options that's available for data center and other customers, and obviously we arrange this so that you can short presentation, but at least to give you some basis so you can make an informed decision as you approach 400 gig deployment. Just before I take questions, I think that I came in right on the 25 minutes or 26 minutes, which is good. We had some requests from a couple customers. So one thing that we are planning is that all of us are in the optical networking world, but what's more useful is actually people networking, because we also learn a lot from our customers and peers. And so, they're having informal, useful discussion on industry trends, technical trends is very useful. Clearly that we don't need to have any confidential proprietary information. So we'll send you some invite later for those of you who are interested. So please join if you're interested. Okay, and it'll be, since we don't have any trade shows physically these days, and it may take a while before you have those. So we thought it'll be interesting and useful to arrange some kind of a group discussion. Okay. All right. With that, I appreciate your time, and I'll be happy to answer some questions from the audience. So Priya, where do I look at for, are there any questions at the moment?
Not yet.
Okay. Okay. Yeah, I know that I try to cover a lot of topics in a short period, in its short time period. So if you have any further questions, please feel free to contact us here. And then Priya, so if you want to go ahead.
Okay. There is one question if you...
Oh, okay.
Yeah.
The question is that do we have information on which 400 gig standards are shipping the most and most popular? I guess you are, when you say 400 gig standards, I'm not sure exactly whether you are asking for the form factors. So again, this is just my personal opinion. I think the QSFP-DD is more popular, and then in terms of I guess volume, clearly the shorter ones typically has more volume because we have more applications. So SR8, 100 meter, 500 meter. So I think that would be my answer. And another question we have is that does the analog AOC support multi-rates or not? I'll double check. I believe they do. I think that they use a chipset that supports multi-rates. So I believe the answer is yes, but I'll double check, and if I'm wrong, I'll get back to you by email. Another question is, could you expand more on TDQ? Yeah, that one probably gonna take some time, and I'm not the expert on it. There's a lot of actually the test equipment experts on this seminar from like VRV and Expo on this seminar as well. And so that's why we thought that having some user discussion group might be more useful. So we'll try to have the forum to discuss those measurements. Okay, so yeah, there are some questions more on AOCs and TDQ, so we'll get back to you by, we do have all your information, so we'll definitely get back to you by email and send you some further information on those. Okay, thank you very much.
Thanks, Michael, for the presentation, and thank you all for joining. So if you want to rewatch the webinar, we will be uploading it to our website tomorrow. I've dropped a link to it in the chat. And if you have any questions, you can reach out to Michael directly or send an email to info@vitextech.com. Our next webinar will be on February 25th, that is 2 weeks from today. Like Michael mentioned in his presentation, our partner OptiMind has been doing some work on analog CDR-based AOCs. So Dr. Young Son of CTO of OptiMind will be sharing some progress updates on 400G and 200G PAM4 AOCs. I'll be sending out an email with the registration details for that webinar next week. Once again, thanks everyone for joining and have a great rest of the week.
Yeah, thank you everyone. Stay warm.